Here we will use 6 switching devices, that is 6 IGBTs to get sinusoidal output using DC voltage source. IGBT will on when gate pulse is applied. Gate pulse, 6 gate pulse are shown here: G1, G2, G3, G4, G5, G6, and 6 IGBT are here: 1, 3, 5, 4, 6 and 2. Here upper 3 IGBT are connected to DC positive terminals of the source and rest 3 are connected to negative of DC supply. Here in output we will get VAB, VBC and VAC. Here VAB is shown here, it is not mentioned, but this is VAB, and we will only focus here to get output voltage VAB, and other 3 can be drawn like VAB. Okay. The DC supply is 560 volt for 3-phase diode rectifier. Diode rectifier not shown here, but we are not interested with the numerical value 560 volt here. We are only interested with the VS, and we will see how VS will be reflected in output. This will be the final output VAB. If you want to know how 560 volt is got, you can mention in comment box. I will explain how to get 560 volt. Actually it will be 1.35 into VS. VS will be the RMS value of the supply voltage 415 volt. 6 switches that are 6 IGBTs here are mentioned with numbers. They are 1, 3, 5, 4, 6, 2. 4, 6 and 2. These numbers are being given for each of explanation. You can see we will trigger here G1, G2, G3, G4, G5, G6. If you will not mention like this 1, 3, 5, 4, 6, 2, we can show here serially G1, G2, G3, G4, G5. This is basically for ease of understanding. In many books it is mentioned as standard. We will on each IGBTs, for example IGBT 1, 2, 3, 4, 5, 6, and therefore 120 degree, and off them rest of the cycle. But during this 120 degree, in between this 120 degree, at 60 degree, next 5 resistor will get on. That is, at each 60 degree a new device will on and remain on for 120 degree. जैसे कि यहाँ पे G1 को ट्रिगर किया है 0 डिग्री में, यहाँ पे हम 0 डिग्री लेते हैं, यहाँ पे 60 डिग्री, यहाँ पे 120 डिग्री, 180 डिग्री, 240 डिग्री. This is finally here 360 degree, 300 degree, finally 360 degree. Okay, this is the expected output VAB. We will divide into 6 parts. with 60 degree apart. So G1, G2, G3, G4, G5, G6. These are gate signals that is required to turn on IGBT 1, 3, 1, 2, then 3, 4, 5, 6. That is why you have written here 1, 3, 5, 4, 6, 2. We don't have to remember. If it's not mentioned, we have to say here G1, then G3, G2, G5, then G4, something like. So in order to mention it serially, we have mentioned here 1, 3, 5, 4, 6, 2 in upper and lower ramp. Yes, this is why it said that it is 120 degree switching. Means if G1 will on here, then it will remain on for 120 degree. So at the end of the first cycle, so G6 is on here. So if you will see what are just before this start of this cycle, so G6 will be on here, and here somewhere here it will on, and it will continue to on 120 degree. So here we have shown G6 is on here. So you have understood this portion. It's very easy to remember. G1, G2, G3, G5, G6. Now let's see what happens when switching starts. We should be very careful while watching. During this first 60 degree, we see G1 and G6. These two switches are on. G6 was on somewhere before 60 degree, and G1 here on start here, and G1 will remain on for 120 degree, and after 60 degree G2 will on, then G3, then G4, then G5 and G6. As G6 was just on before 60 degree, so G6 is on here. It is continue like here. It's continue. Okay. Now, as in first 60 degree first phase, here G1 and G6 are on. So here this switch will be shuttered here, and this point shuttered, and this will be shuttered here. So this Vs, a total voltage supply from here to here, Vs. If you will use diode rectifier, it will be 560 volt, but we will see here only Vs. So Vs, this Vs will be conducting through this IGBT, then it will, as shown in dotted, it will reach here and here. This will come here across Z1, and here negative supply, it will be connected through G6 and reach here to Z2. As in case of a motor something, it will be Z1 will be also Z, Z2 also Z, and Z3 also Z. As in case of winding of a induction motor. So this voltage Vs will appear through this IGBT, and it will be reflected here, Vs positive supply. Then the negative supply will be connected to Z2. See what happened here. The Vs reached here. This is Vs positive terminal of Vs reached here, and negative terminal of Vs reached here. So what will be Va? As it is two, you can say two impedance or two resistance. So VA will be VS will be divided here. Other things are these switches 5, 3, 5, 4, 2, these are open. So there is only path active here through this. So what will be voltage across VA? VA will be VS divided by 2, as in case of voltage divider rule. So we'll plot here. It will for easy to understand. I have drawn six conditions here. We'll mention here and plot this voltage here in graph, so that we will not make any mistake. It will be very clear. So VA will be VS by 2 and VB will be minus VS by 2. It will take it will connect multimeter one terminal here and measure VA with another terminal. It will be shown VS by 2 supply, and here to here in multimeter it will be shown minus VS by 2. Here we have divided the voltage, and whole VS will be appear against these two impedance or resistance, whatever. So VA is VS by 2 and VB is minus VS by 2 with respect with this neutral point or 0 volt. So you will plot the voltage got here for VA and VB here. For this 60 degree, VAN will be VS by 2, VBN will be minus VS by 2, and after 60 degree this G2 will be start conducting, and G6 gate signal will be withdrawn. So G6 means 6 number IGBT. So now we'll see after 60 degree what will happen. After 60 degree this will be here. We'll check first here from we'll draw this G1 to G6 first, then we'll see this from 60 degree to 120 degree. This second phase, what happens? Second phase, this will 1 and 2, first and second IGBT, this will be 1. Here IGBT 1 and IGBT 2 will be on. So voltage will be available here to VA, and through 2 negative supply will be available here in VC. We will show VAN only here, and VCN here it is shown, but we are not interested with VCN as we are going to this show the output for VAB only. Okay. So the voltage you can voltage you got can be shown here. This is VA is VS by 2 and VC is equal to minus VS by 2. Okay, VC is equal to VS by 2 and VBN is 0 here. Okay. So likewise we can see next in the next cycle from 120 degree to 180 degree, G3 and G2 will be on, and corresponding voltage that will appear here we can mention here. It is also already mentioned here for 6 stages of a cycle. Okay, now we will see VAN we got like this. and VBN. Using all these voltages, we will draw here VBN 0, then Vs by 2 0, like this, and from these two curves, two trends, we will get VAB. VAB is equal to VAN minus VBN. VAN is Vs by 2 here, and for first 60 degree Vs by 2 here, and this is minus Vs by 2. So output will be Vs, and for next cycle it will be Vs by 2 minus 0 is equal to Vs by 2. This is Vs by 2, and for next cycle it will be minus Vs by 2, then minus Vs, then minus Vs by 2. It will be continued like this, and the waveform is similar to that of a sinusoidal waveform. So, this is for VAB. I mentioned again, this is for VAB. It is not shown here. Okay, VAB, and like this we can get VBC, VCA also. So what we do here, पहले तो ड्राइंग ड्रा करेंगे 1 3 4 1 3 5 4 6 2. ये तो इजी है ड्राइंग ड्रा करने के लिए. देन विल ड्रा दिस पर्सन G1, G2, G3, G4, G6. G1 from starting from G1 120, it will be 1 for 120 degree. G2 will be then after 60 degree 120 degree, like this from G1 to G6. ये ड्रा करने के बाद फिर हम लोग इसका स्विचिंग पैटर्न देके इसका वोल्टेज सप्लाई यहाँ पे लिख देंगे, एंड जो आउटपुट होगा VAN, देन विल ड्रॉ VAN, and then we will draw VBN from this outputs. Finally we will draw VAB. So this is the end of this topic, and hope it was helpful for you. So if you think so, just like it.